Good morning everyone. Welcome to another episode of XR Talk Show. So today we are going to do Wolfram language tutorial, Wolfram language for programmers. If you are a beginner, that's good. But this is designed for programmers. So Wolfram language. So let me show you. So let's go to Wolfram language. So I did several videos before on graphics and on several other things. I have like over 10 videos on Wolfram language. But today is going to be from the ground up. So, I teach you the complete thing, Wolfram language. Hello, Oflamio, thank you. I only watch product placement. Thank you, Oflamio. So Wolfram language. So let's begin. Okay, so let's see. Okay, so today's talk show. Let's go to. So let's begin. So Wolfram language tutorial, and you can just search for XR WolframLang, and you'll find my tutorial. Okay, so XR Wolfram language tutorial, and this is what we're gonna cover. So whatever I talk today is all written up. So if you prefer to read, you can read the whole thing. This is the most condensed. Now let me tell you what this tutorial is about. This is not for people who never programmed before. Okay, but this is for people who never programmed, who never used Wolfram language or Mathematica before. And especially it's designed for programmers, like for you guys who program in Python, Java, JavaScript, Golang, PHP. If you are a programmer, you'll find this tutorial very helpful. There's, you'll find it very helpful. And I'm not going to cover mathematics, like how do you use Wolfram language or Mathematica to do equations, to solve linear algebra, to derivative calculus, that kind of thing. So that is often used for Wolfram language, but I'm going to just teach you the programming, how do you program it, and in particular understand how it works, because Wolfram language is a term rewriting system. It's based on, it's a symbolic pattern matching replacement system. That's what term rewriting is. So this is unusual. You do not see this language in just about any language, not in Haskell, not in Clojure, not in Lisp, not in functional, very rare, So I'm going to teach you that, okay? And I hope, so this will be like 1 hour. And let's see, so Wolfram language tutorial, and what else I want to say? So where do you download it? You download it here. It's free. It begins to be free about 3 years ago. So you can just look at Stefan Wolfram's post about releasing it free, and then you can read my tutorial about it. You can download it here. So where do you download it? Here, Wolfram for developers. Okay, you need to register. You need to give your email, and you can get it. So what you'll get is Wolfram, or you can also buy Raspberry Pi kit. It comes with Wolfram language, come with it free. That allows you to run Wolfram language or Mathematica on the Raspberry Pi, but not outside. So, or you can just buy it, and which I recommend. I recommend you just buy Wolfram language or Mathematica, and because it is a lifelong tool, it's great for it's as a lifelong tool. Especially if you are interested in mathematics, in sciences, chemistry. You need to do a lot of math, not just math, and programming as well. So programming is what I'm gonna teach you today. Hey, George from Romania. Hello. Hello guys. So okay, so that's the background. That's where you to download, and let's see what else I want to say. Wolfram language. So, and let me also tell you, Wolfram is a bit confusing. There's a lot of jargons. Wolfram engine, Wolfram script, Mathematica, what's the differences, and so on. So Wolfram engine is the free download. You can download it. That's like the compiler. That's a compiler. Wolfram engine. Okay, that's what you need. And Wolfram script is a terminal interface to the Wolfram language. For example, let me show you, okay? Wolfram script. So right now you are looking at Wolfram script. It comes with Wolfram engine, okay? So if you download Wolfram engine, Wolfram script is the basic interface. Let's say 33 plus 2. Okay, 35. So let's do something, let's do something more complicated. Expand some 8 over x squared plus y plus x third power y. Okay, and I need so expand that to the third power, and let's add a square root somewhere, okay? Plus square root x squared plus y. Okay, let's see what happens. Okay, so you got this you got this equation. So that's the Wolfram script. That's the interface to the Wolfram language, okay? So Wolfram engine is the compiler, Wolfram script is the interface. Then there's another interface when you buy Wolfram, if you buy Mathematica, or if you use a Raspberry Pi, then you'll have the graphical user interface. So let me demonstrate. So here is the graphical user interface. So let's enter the same equation. Let's put it here. Let's enter the same equation here. Copy, paste it here, evaluate. So you got this more beautiful, typesetting mathematics. Okay, that's about the Wolfram script. Is the command line interface. Wolfram engine is the compiler, and the Wolfram notebook is is the graphical user interface. Okay, that's the interface part. So I've been going for 10 minutes. So let's begin Wolfram language, okay? So I'm going to teach you from the ground up. So first of all, so let's see. Wolfram language. Okay, hold on a second. Let me go to my talk show. Today's talk show here. And let's post the link. Okay, delete that, show in browser. Okay, so that's my Wolfram language tutorial. So okay, so first of all, let me show you strings. Okay, Wolfram strings. This is a string. Okay, so string is the most basic in every language. You in Wolfram language you quote it with a double straight quote, nothing else. You cannot use single quote, you cannot use triple quote like Python and so on. That's the only way. Okay, just double quote, straight quote, string. So that's a string. And if you want to print something, you say print. Okay, so print 3 plus 2. Okay, so that's print. You can use, you can do it here as well. Wolfram's Wolfram script. Then I'm gonna show you, my Wolfram. Let me show you my Emacs interface to the Wolfram language. Okay. XOR Wolfram Emacs. So if you just search that, you can see XOR Wolfram mod. So this allows me to do Wolfram language in Emacs. Let me show you. So copy that. So if you have questions, comment, post it, okay, about Wolfram language. So let me show you my Wolfram script mod. Okay, the pink window shows all my command calls, and as I move cursor or if I delete something, everything shows in the pink window. You see all the command calls and all my keystrokes. Okay, so let's start a Wolfram language. So let's paste. So you can see. Let's try to evaluate this the same command. Okay, so I press a key. Error because I need to exit the Wolfram language from the terminal. For some reason, it only allows certain instance of Wolfram engine running. Okay, so now I run it. Okay, you can see the output. So you can see the output is here. So this is this I'm using the Wolfram mod. You can download it for free. This is how it looks like, and it's on GitHub. Okay, so let's show turn on JavaScript. Okay, so this is a Wolfram mod. You can download for free. For example, I can do completion, expand, press it, and there, it auto completes. By it has built-in. It has about 7,000 built-in commands in Wolfram language. Okay, so anyway. So string, we covered string. So let's go to the next thing. We covered string. We talked about Wolfram engine. We talked about several interfaces. The Wolfram script interface, the Wolfram notebook interface, and Emacs interface. Okay, strings. So let me tell you, so strings, so how do you get the length of a string? So that's string length, okay? So let's say ABC. Okay, that's the function for string. Now in Wolfram language, everything you do is just a function call. There's no special syntax. Let me talk about this. So in other languages, for example, in Java, you have objects, you have class, you have references, many complex things, and the syntax is different. You have for loop, special syntax. You have you have while loop in C and C++. You have I++ syntax. You have those sort of syntax. You have class. You have object. You have you have different data types. Now and similar in Java and so on. In Wolfram language, everything is just a function call and expression. Everything, okay? There's no class, no special, this is a special thing. This is a special object. This has inheritance. There's nothing like that. Nothing. Everything is just a value, okay, expression. And everything, the way you compute is just call a function. Everything. There's no class, nothing else, okay? The most simple possible. One rules governs the whole language, okay? So string length is a function that returns a number of characters in string, and you can also have Unicode in it. But let's skip that. Then if you want a new line, it's similar to other languages. You put a \n, for example. Let's say \n. That gives you what? Oh yeah, well, not there. So you are doing string length here. So \n cd, and that's going to be 2 lines. Okay, so that's a escape character. Okay, then string functions. So you have string length for the length, and you have string join. This is how you join 2 strings. So let me show it because string join. Okay, so let me show you this because it illustrates another thing about Wolfram language. A, B, C, D, E, F. Okay, so that joins to string. Now there's a shortcut syntax. So you can say A, B, C, then that's a shortcut for string join. D, E, F. Okay, so you can see that. And you can do similar in, you can do, for example, comment that out, run it. Okay, so you can see there it is, the output A, B, C, D, E, F. Okay, and similarly you can do it in Wolfram script. What? What? I think there's a bug. Yeah. 1 plus 3, 43, okay. Now paste that to it, okay, there it is. For some reason it screwed up before. So shortcuts, okay, many Wolfram language, remember Wolfram language is just functions and expressions, values. There's no object, there's no parents, relations, there's no instance of something, there's no such thing. There's no exceptions, okay, there's nothing. Everything is just expressions, value. You change the value by applying a function. Now, I'm being a bit repetitious. This is important because this is the whole, you have to remember this in your by heart because this is the whole principle of Wolfram language, okay? Just functions and expression, nothing else. Now, functions, many Wolfram by default, there are 6,000, 7,000 functions. So let me show you a list of all functions, okay? So, for example, you do that, names, okay? So that shows all the functions in Wolfram language, okay? So you can see there's a lot, mathematics, anything. So, and let's see how many are there. So let's see, let's go up. So you can say, so length is the general way to see how long is the list, okay? So you see, there are 7,000 built-in functions. You don't need to load libraries. No libraries. Like if you need to do regular expression, I need to load what library is it? If you need to go over a directory, get all the files in a directory, you have to, do I need to load system or import system or nothing like that, okay? So if you want to know all the directories of a file, for example, you can just do this. I believe I'm getting ahead of myself. So let's go back to one thing at a time. So we'll get to it. So shortcut, okay. Remember, shortcut is important because many Wolfram language, it works by functions. You just call functions, find the function you want, call the function. That's how you do computation in Wolfram language. Function names are always very long. For example, string length is very long. String length, string join. There's no, function name are full. That means you can always find the function just by searching function names, and you will always know what the code does by just reading the function names, just like Lisp, okay? So function names. But the problem is typing it. That's why many functions has a shortcut. For example, string join is done by that. And for example, let's give another example. So how do you create a list? It's like that. Okay, 3, 4, 5. Okay, that's a list or array. Depending on which language name. But this is called the list or array in Wolfram language. A list. And shortcut for you see it output like that, so that's a shortcut. So if you want a list 3, 4, 5, that's a list. So the important thing to remember here is that this Wolfram language, everything is a function. Okay, everything is this syntax, function name followed by square brackets and something. However, some function has a shortcut, so list is done by using that. So for example, we can say, let me show you some of the shortcut things. So for example, list 3, 4, 5, true. Now what is that equal? That is a shortcut. So that shortcut is same Q. Let me show you, okay. So this expression you are seeing is a shortcut for this expression. Okay, so remember, everything is a function, and functions are full names, and some function has shortcut. How do you find the shortcut? If you look at the Ufm documentation, they are mentioned the shortcut, okay? So we already 20 minutes. We kind of going too slow. So let's look up Ufm documentation. Let me show you. Okay, Ufm documentation. So this is the official Wolfram documentation, 7,000 built-in functions, so there's a lot to go through. I'm not covering, of course, I'm giving you the basic principle today. So this, read them, okay? So in here, the Wolfram website, the documentation has the same documentation, exactly the same as when you use a, built-in from Wolfram language. So they are exactly the same. Okay, so let's look at one of them. So, you see, you look at list. So, for example, I click on list, and you can see, the Wolfram crashed. This is bad. Demo, and it crashed because I was trying to increase the font size. Anyway, this is how you do it. Okay, so you can see the documentation again. Now increase the font size. You see this part that shows the shortcut for this function named list. Okay. Okay. So let's go back. So I need to go quick. So what else? So we covered. Let's Okay, so we covered a few things. Let me explain. So let's write it down. Everything is expression. You compute by calling function. Okay. Every 7K built-in functions. Okay, no need to load lib. Okay, there are libraries, of course, but you don't have to load them. There are also external libraries, so you can have add-on and things, but by default there are 7,000 built-in functions. No need to load library, and every function name is full, so you can understand by just reading the function name. Okay, so that's some of the principles. And okay, then many commonly used functions has a syntax shortcut. For example, plus 1, 2 can be written as 1 plus 2. Okay, so that's some of the things we covered. Now let's so we covered now let's go back to we are talking about string. So now you know that, so how do you join string? How do you repeat a string? How do you do regular expression? How do you, everything about string, now you almost already understand how to do it, because everything is just a function. You just find the function name you need, and for the string functions, all string functions will have the name string in it. Okay, so let's show an example. So this is the power of being of this system. Everything is a function name. So if you want to know all functions that contains the word string, anything, when you are working with string, all you have to do is just find the function. So usually there's a lot: string join, string length, string match, string pad left, string part, that extract string, string partition, that divide the string into a list of strings. Okay, string position, find the position of a string. So there it is. So that's so basically, like, we don't have to cover, like usually in other languages, string join, you use a plus sign. Then there's a method string join, you string dot join, then there's when you want to do regular expression, you need to create a regular expression object, then something like that. So Wolfram language is now you already understand everything. Oh yeah, essentially you already understand everything you need to know about string. String is just double straight quote, and anything you want to do it is a function. Convert string to numbers, string drop, which delete parts of the string. Okay, delete a continuous sequence of string. String delete allows you to delete several characters. So string free tells you whether a string contains a pattern and things like that. Okay, so let's do a regular expression examples. Okay, so and by the way, everything I talked today is all in my tutorial. Okay, so everything I talked about how to list functions here and how do you show the documentation of function is already on my website. Okay, so you can just read it. Now let's do an example of regular expression. So let's say I want to know something. Let's get the email address. Okay, so kasai@kasali.org. That's my that's my primary email address. Something, say some cat. Okay, so that's a string. Now suppose you have a huge string. I want to extract the email address. So how do you do that? So let's do string parts. I think that's the function. Okay, string cases. You can, so what is the argument to a function? You click on that, it shows you the documentation. You can do it in the same way you can do it in Wolfram script, but you have to use. Anyway, I'm not going to go. Anyway, let's get focused because there's a lot to cover. So string cases. So let's just look at the documentation here. String cases. Okay, string or pattern. Okay, so the first argument is a string. There. The second argument is a pattern. Now, first of all, I can just say XOR. Okay, so let's say just a literal. So string cases will return all substring that contains this pattern. In this case, it's a literal string XOR. So you get two occurrences of XOR in this string. Okay. Now, but you can use a regular expression. So the second argument should be a regular expression. So how do you do that? So you do that by regular expression. Not surprising, the full function name regular expression. Okay, so now you say, let's try to capture the email address. Well, we can just do XOR. Okay, same thing. But now let's try to use a pattern to capture the email address. So that will be anything A to Z. Let's just do it simply. Okay, let's forget about the proper formal email address. So anything A to Z, one or more, followed by a @ sign, then A to Z again, followed by a dot. Now a dot in regular expression means any character, so we want a / dot, means a literal dot. Then let's say org. Let's just make it simple. So we got it wrong. So one or more. So there it is. So you see, this is an example of using regular expression to extract email address. Okay, so far so good. How am I doing? So how many people are watching? 5. Grand total of 5. Great. Okay, so let me so we've been going over this string, and we've been wait, why is there an error? 2 hexadecimal digits are required after \. Oh, okay, so you need 2 \. Oh God, Wolfram language has toothpick syndrome, just like Lisp, because the only way to quote string is double quote. There's no special string for regular expression. So whenever you need a backslash, you actually need two backslash. So let me have a drink, sip. Okay, so let's go back. So we'll go on string. Okay, so string functions, and we covered regular expressions. So with regular expression, you can extract substring. You can also so here's a documentation for regular expression. Okay, so with so many string functions, they take an argument that's a regular expression. Okay, so string cases is one of the example when you want to extract part of the string. But there's also string match Q that checks if a string contains a pattern, list to string, insert into string, delete substring. So you can also use a pattern to delete substring, which is this function string delete. And you can also search test pattern matching. All these string. So string starts, check if a string start with some pattern, or string ends, string match Q, string contains Q, string free Q if it doesn't contain some pattern, string position. You give a pattern and it returns the position, the index where the pattern occur, and string count returns the number of occurrences. So all these functions, most of them return, they take a pattern regular expression. Okay, just like our example here. And when in Wolfram language, when a function ends in a capital Q, that means it returns just two things, true or false. Okay, the Q stands for question. So it's similar to Lisp, where these are called predicate functions. So in Lisp, such function returns such function name ends in a P. Okay, P for predicate. In Ruby, for example, such function ends in a question mark. And also in Scheme Lisp, they end in a question mark. So this function, when those functions means they either return true or false, nothing else. So in Wolfram language case, the function name ends in a Q. Q is a reminder for question. By the way, this is the art of naming issue. So why does Wolfram ends in Q? Why doesn't it ends in P as in predicate, the traditional way? Well, because predicate, what the fuck is predicate? Most people don't understand it unless you have studied logic. So Wolfram language, the design, the naming of things, they tends to be very more understandable. So Q just means a question. Okay, so there's a question: does Wolfram language have Lisp-style reader markers? No, it doesn't have Lisp-style reader markers. But however, you can define your own operators, but you cannot. You can define your own operators with with semantics to go with it. But you cannot. It's not like Lisp. You can redefine in some minor way the way it passes the nested syntax. Okay, so if you want to do anyway, so that's my answer. Okay, so anything so let's go on. Okay, so we covered string. Okay, so we already talked for about 40 minutes. This is not going to it'll take another hour to finish. So far we covered string and some very basic way how the Wolfram language functions works. Okay, we covered string. Then Then you have basic, arithmetics. How do you add? How do you subtract? Which is very simple. Let's magnify. Okay, so hold on a second. So let me think about where do I want to go now? Should we, because there's a lot to cover, because we haven't get into symbolic symbols, symbolic computation. What does symbol mean? Because so far we only cover string. Then symbol is the most important thing, and list is also the, basically list and symbols. That's the heart of Wolfram language. Then we need to cover pattern matching, and we need to cover expression structure. Then symbolic pattern matching. And there's also other things like true and false. That's very simple. Equality test. Very simple. If then else in every other language, very simple. And Wolfram has which or switch, both, like conditionals. But these are in every language. But so what's more important is what I want to cover specifically about Wolfram language. That will, if you understand it, you'll know a lot about Wolfram language. That's the symbol and the list and the expression. Okay. So, but I don't think today, 40 minutes, it'll take another hour to do. So Wolfram expression. Okay, so let me think. Then we have to cover Wolfram functions. So any other comments or questions? So the question is, so you couldn't make your own string syntax that's better suited for writing regular expression. That's correct. So I guess you identified a flaw of Wolfram language. Yeah. So no, you cannot. The Wolfram language string, I would say, is somewhat painful. It's just like Lisp. Okay, so that's the case with Lisp as well. I'm going to digress if I talk about this, because the reason this in Wolfram language and in Lisp it's like that is because they stick to a very simple principle. So if you want a string, there's only one syntax, double quote. Well, I guess what you are saying is that in common Lisp, for example, or in other, in common Lisp, if you are very, very advanced common Lisp user, suppose you studied coded for 5 years common Lisp, then you can use the reader macro, which is different from macro. So you use the reader macro feature to change the syntax so that you can create your own. But I don't think that's practical, because not very few people do it. And in Emac Lisp, for example, you don't have reader macro. Okay, so in Emac Lisp and in Closure Lisp, you do not have reader macro. It does not let you change the define reader macro. Okay, in Emac Lisp and in Closure Lisp. I'm not sure what's the case with Scheme Lisp, but I do know you can do that in Common Lisp. However, very few people do it. It's usually just, you don't see that in real life code. Yeah, it's a feature, but you don't see that. I would claim you almost never see it. Basically, you never, practically speaking, you never see it. So anyway, so that's so you do have common escape sequence. So so you have escape sequence like /n, /n, /t for tab \quote for escaping double quote. You know, if you want to know, you can find a list of them. So let's just Wolfram language. So let's go back to let's see, where's the documentation? Okay, so I need to turn on JavaScript. So these are kind of confusing, but basically there's only one product, okay? Wolfram language or Mathematica, they are essentially the same thing. Mathematica just refers to the product, you know, with so you can do all these graphics. But I want to go to the documentation. There it is. So yeah, so what we are talking about, string. So yeah, string escape. Oh yeah, I need to turn on JavaScript. So where is the properties of string special characters? Where is a list? So we want to know a list of all the escape sequences. You know, Wolfram language, they have like 1 million pages. It's fairly overwhelming. I read, you know, anyway, I don't want to get over, you know, you can find it in a few minutes. Let's go back to the Wolfram language. So we covered string. Yeah, I think maybe we let's do it next time then. I mean, so yeah, that's too bad. I cannot finish unless we take another hour to let's do it in a few days. In my next YouTube we'll continue with others. Kind of disappointing because this video is not complete. SSPPA. So who are you? What's your Discord name? Show the Discord name so I can show your Discord name so I can unban you. Hey Justin, do you have to pay to use Wolfram language? No, it's free. So, but you can buy it if you want. I recommend you, or you can just download for free for developers, for internal development. You know, read their license agreement. So Zerson, hey Zerson, so do you think Wolfram Notebook is great for math taking notes? Yeah, it's fantastic. Okay, I was going to we kind of see how long, 47. Yeah, that's it for today. So that's it for today. We shut down in 5 minutes because I cannot cover the whole other things. Let's do something fun, okay? So notes. So typesetting. So let's show some interesting things, okay? Let's say nest a function 3 times, okay? Next, we want to nest recursion, basically. The function f with the argument x and 3 times. So do it. You see, because Wolfram language is symbolic, so right now we don't have a definition for f, but however it still works because it just returns symbols. But now if you actually define f, so let's define f, okay? Let's say define f. Let me do the full syntax so it's easy to understand. So let's say function. So it's a function of x. So and what do you want to do? Let's say 1 over x. Okay. So that's a function. Now if you evaluate the recursion, you know, recurse f 3 times, the first argument being x, what you get? What? Wait. That's not, is this correct? So what is f3? So what is ff3? What? Oh, it's a... Oh yeah, so it just invert. Yeah, that's right. If we say 4, it's gonna be x. That's right. So this is not a good function. I want the nesting. The behavior is correct though, but so I want to define, let's say 1 over square root of x. So we define a function to be that 1 over square root of x. Now let's do the nesting, okay? So f at 3 is that repeated. Okay, so but now what if you give a symbolic value? Let's say fx. Let's say t, okay? So you get a symbolic value. What if you repeat it twice? Let's say t, let's say y, okay? Why is it the value? So anyway, so let's try to repeat. I don't, you see, what I want is, I want nesting. I don't want it to simplify. Right now it's simplifying because it simplifies because the way our function works. So let's prevent it from having a simple simplification by doing that, okay? So we define function to be 1 over square root of x plus 1. So now we evaluate. Now you can see the nesting. Evaluate, fantastic. Evaluate, fantastic. Now evaluate it, recurse 3 times, fantastic. Okay, so is it? Yeah, so it's great for typesetting. Okay, automatic. Any question? Any other questions? I think that's it. I think that's it for today. Okay. Yeah. So thank you guys for watching. Bye, guys. I'm shutting down in 2 minutes. So there's a question about keyboard. Well, you have to question about keyboard. Using a mouse a lot and the keyboard is real wide. Can it because of my mouse usage? Elbow pen. Yeah, I don't know. It depends on your situation. You have to take a photo and show a photo. Hey, Raisin. So we have a lot of people watching, background watchers. So thank you guys for checking in from Romania. Okay, bye guys.